We're going to review graphing absolute value functions. So once again, this is our standard form for an absolute value graph. So we have f of x equals a times the absolute value x minus h plus k. So remember, a is our slope when we are graphing. H is the x value of our vertex. And remember, it's really important that with h, we take the opposite of what we see, because that negative sign is built in to the function. So you take the opposite of what you see. And k is the y value of your vertex. So altogether, your vertex is going to be hk, and then you're going to use a to find additional points on your graph. Let's take a look at this. So in this example, I have f of x equals 2 times the absolute value x minus 6 plus 5. So my slope is going to be a, so it may help you to rewrite what the standard form looks like underneath, so that it's really easy to identify all of our pieces. So in this case, a is 2, okay, and our vertex is going to be hk. So in this case, h, I see negative 6, so I take the opposite of that. That's going to be positive 6. And then k, what you see is what you get. So my value of k is 5. So I'm going to start by plotting my vertex. So I'm going to go 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So right there is my vertex. Okay? And from there, I'm going to use my slope to find additional points. So I start at my vertex. I'm going to go up 2 over 1. There's the next point on my line. Up 2 over 1. So there's half of my v. To find the other half, you go back to your vertex, go up 2 over 1 the other way, up 2 over 1 the other way, and that's the other half of your v. The next example we're going to look at is f of x equals negative 3 times the absolute value of x plus 4 minus 2. Once again, it may help to write your function in standard form underneath so that you can easily identify the pieces. So here, I'm looking for a for my slope. My value of a is negative 3. For my vertex, I need hk. Again, with h, you need to take the opposite of what you see. So I see positive 4, so that means my value of h is negative 4. And k is negative 2. So you start with your vertex, 1, 2, 4. So negative 4, negative 2 is right there. And now I'm going to use my value of a, my slope, to find additional points. Since my slope is negative 3, I start with my vertex. I go down 3. 1, 2, 3, and over 1. Down 3 and over 1. So there is half of my v. To find the other half, you go back to your vertex, down 3 over 1 the other way. Down 3 over 1 the other direction. And there's the other half of your v. This one is both simpler and sometimes more complicated because a piece or two is missing. So again, I'm going to suggest that you write your standard form underneath. Okay? So when we look for our slope a, it doesn't look like there's a number in front of our absolute value, but remember, a is multiplying by that absolute value. So if there isn't a number, what we're multiplying by is 1. So in this case, a is a positive 1. I need hk for my vertex. I see negative 3, so I know that my value of h is positive 3. And k, there's nothing back here. We're not adding on. So we're literally adding 0, which means the value of my k is 0. I'm going to plot my vertex at 3, 0, and use my slope of 1 to get me additional points. So there's half of my v, and there's the other half of my v. The last example we're going to look at, again, a piece or two is missing. Once again, my value of A doesn't look like there's anything in front. So when that happens, we're really multiplying by a 1. Okay? So A is 1. I need HK for my vertex. So nothing is being added or subtracted from X. So another way that I could write this is the absolute value of X minus 0 plus 6. So in this case, H is 0. And my value of K is a positive 6. So I have 1, 2, 3, 4, 5. So there's my vertex. To find additional points, I'm going to use my slope. There's half my V. And there's the other half of my V. And that's graphing absolute value functions.